Students, good morning. So this is your first lecture of module number 3. Okay, the title of this module is Velocity and Acceleration Analysis of Mechanisms by Analytical Method. Okay, so this is your first lecture, and in the module number 2 already you have studied how to find the velocity and acceleration of any kinematic links or any four-bar mechanisms using instantaneous center method, right? So it is also saying only we have to change the method. We are using some standard equations, some derivations to find out velocity and acceleration of different kinematic links of mechanisms. Okay. So as the title says, we are finding velocity. It means angular velocity, angular acceleration. I'll come with this analysis. What is exactly this analysis? Okay, in the next slide. And mechanisms means for your syllabus. Just wait for a second. Some more students want to join the class. I think so. Yeah. So whether this slide is visible, please let me know. Anyone? Okay, thank you. Yeah. Okay. As I said, in this module, you are finding the velocity and acceleration of mechanisms. Okay. So for your syllabus, a four-bar mechanism is there and single-sided crank mechanism is there. Okay. By using analytical method. Analytical method. And whatever I'm going to solve the problems, you'll get the same thing in the examination. Almost similar problems. Okay. Uh, let's get started with today's lecture, that is lecture number 3.1 of module number 3. Yeah, that is velocity and acceleration analysis of mechanisms by analytical method. So before I start this module, I'll exactly explain what is exactly this analysis, and there is one more word called as synthesis. Okay, the first unit is regarding the analysis of mechanisms, and the second unit of this module is synthesis. Just note down. Okay. So first I'll try to correlate what is exactly analysis and what is exactly synthesis. I'll compare both the words so that you'll get one problem on this analysis on unit 1, and you'll get one problem on synthesis on unit 2. Both covers module number 3. First I'll start with this analysis. Just consider any one system. It may be a mechanism, it may be any machine. You are giving some input to that machine or system, and you'll get the output, right? In the case of analysis, already the system will be existing. Okay, already the system will be existing. You can consider any lathe machine. Okay, that is as a system, and you are giving input. Input means you are giving some electrical power supply, right? You are giving some input, and you are finding the output as you are supplying some electrical power. All the uh, rope drive starts rotating, correct? As the rope drives starts rotating, the check of the lathe machine will start also rotating. It means you need to find out the output. What is the speed of that 3-jar check or the 4-jar check? It means in general I can say that there will be a already existing system, and you know already what are the inputs, and you need to find out the output. It means here in the analysis part, we establish the relation between the input and the output for already existing system. Just remember, just note on this. Already the system will be there. Only you need to find out what is the output, and you have to correlate with the input. That is the analysis part. And what about the synthesis? Synthesis means already you'll be knowing the input, and you'll be knowing what is the required output. Okay. Only you need to design this system. The mechanism will not be existing. Only you know what is the input and what are the required outputs. Already these things will be there. According to the requirement, you need to design any system. So that comes under synthesis. Here we'll design the system for known input and output. So this comes under synthesis. And I'll take this example of this conveyor. Okay, please concentrate. There's a rotary conveyor here, and there's a linear conveyor, you can say. There are two conveyors, and I want to transfer these workpieces, these white color workpieces, you can say. Can consider this as a cold drinks, and I need to transfer these cold drinks from one conveyor to another conveyor. So I'm taking the help of this robot. Okay. So first I'll consider this robot as a system. It is a mechanism or it is a machine. Okay, I'll consider this as a system, and I'm giving some input to this system. To move these robotic arms and grippers, I need to give some input, that is a electrical supply, right? And sometimes I need to give the pneumatic power supply or hydraulic power supply to operate these grippers or the end effectors. Then only these robots can move. Correct? Already the system is there, correct? And you are giving the input as the electrical power supply and the hydraulic power supply, and you are getting the output. What is the output? There is a rotary motion or the semi-rotary motion of these arms and the grippers. You can see the arms are moving from this point to this point, like this. They are rotating by some angle. So that is the output. It means for already existing system, you know the inputs and you need to find out the outputs. The output is nothing but what is the angular displacement, the angle that is covered by this arm, and what is the angular velocity, with what speed it is rotating, and what is the angular acceleration. Those comes under output. The input is high voltage power supply and hydraulic power supply, high pressure air or high pressure hydraulic oil. The pressure or the voltage is the input, and the output is the displacement, velocity and acceleration, correct? And you already have the system. You have the system. You need to find out the relation between the input and the output with respect to this system. If you are increasing the power supply, what is the output? Is there any change in the angular displacement or angular acceleration or angular velocity? Okay, that comes under analysis. Okay, and in the first unit I am to deal with this analysis part, and in the synthesis part this system will not be existing. Okay, the robot will not be existing. You know what is the input, what is the voltage you need to supply, what is the pressure of air or the oil you need to supply to operate these grippers, and you know how much distance the arm has to rotate, what is the angular displacement, you know with what speed it has to rotate, with the what acceleration you have to rotate. Input is known, output is known, but the system will not be there. It means in the synthesis part you need to design this robot for given input and possible outputs. That is the only difference. Okay, I think I have clarified what is the difference between analysis and synthesis. Please let me know if any doubts. If no doubts, I'll go with this analysis part, that is unit 1. I'm going to solve one problem. So which is if you're able to solve one problem, then you can solve all the remaining problems. So all the steps will be same. First I'll explain what is the standard method. Before that I will explain what is the rules and a list of formulas with respect to the problems. Yeah, if it is clear, I'll go with the next slide. Before that, let me clarify some more important points. Yeah. So let me explain this, what is exactly a motion. It may be a linear motion or an angular motion. So you can call it as a displacement also. So when there is a change in position with respect to time, just consider any kinematic links. If it is rotating from one point to another point, so it comes under motion, the angular motion. Correct? It means change in position with respect to time. The position of the object is changing with respect to the time. Correct? You can consider the wiper of a car. It is moving left and right. Correct? I explained in the first module. It means there is a displacement with respect to time. As the time changes, the position of the I think that wiper is changing. Okay, it is moving some through some angle. Then what is exactly planar motion? Planar motion, it means whenever the object or any kinematic link or mechanism is moving in a single plane along x direction and along y direction. You can consider the car wiper as a 2D motion of a plane. The car wiper is attached to the glass, the front glass of the car. Correct? It means the wiper is restricted to move with respect to the glass itself. It has to move along X and along Y direction, not in the Z direction. It cannot move front and back. Correct? It means the motion of the wiper is restricted to the single plane. Single plane, that is nothing but your front glass. So it comes under planar motion. And one more motion is a spatial motion. If any object is moving in a space along X, along Y, along Z direction, that comes under spatial motion. For your syllabus, only this is there, second one, that is a planar motion, 2D motion in the plane. Means whenever you are writing on a blackboard with a chalk piece, the chalk piece is restricted to only that blackboard. You can write along x-axis, you can write along y-axis. You cannot go inside and you cannot go outside. It means if the motion is restricted to only two directions, you can call it as a planar motion. For your syllabus, this is there, not the spatial motion. And there are different types of motions. When you consider a piston always it will be reciprocating inside the cylinder of an IC engine. Correct? The piston has to move in a straight line itself. The type of motion is the first one is the straight line motion. The example is a piston. And when you consider the crank will be having a complete 360-degree rotary motion that comes under a rotary type of a motion. And one more, a connecting rod. As I explained in the first module, so you can observe the connecting rod will be having the combination of both linear as well as rotary motion. So these are the three types of motions, please note them. So you just consider any mechanisms, any machine, the kinematic link will be having either a straight line motion, either pure rotary motion, or combination of both, combination of linear as well as the rotary motion. And after that, let me explain. Already you know this. Let me explain once again. What is exactly linear displacement? Whenever the object is moving in a straight line like a piston, so there will be change in position. Correct? So I can call this a displacement. How much there is a displacement, the distance traveled along the straight line. So I can indicate with a alphabet S. It should be measured in meters. Okay. And when you differentiate this displacement, you'll get a linear velocity. Okay, the rate of change of displacement is nothing but this linear velocity along the straight line. The object is moving in a straight line. So I can give as v is equal to ds by dt, rate of change of displacement with respect to time. Again, when you differentiate this linear velocity, you'll get a linear acceleration. This is nothing but rate of change of velocity. The velocity may not be same all the time. It may be changing with respect to the time. So I can call it as a linear acceleration that comes under meter per second square. So I can indicate with a small letter a. In a similar manner, when the object is rotating, so you can consider this as a OA as a kinematic link. Okay, this is a single kinematic link. Point O is a pivoted or fixed at this point, and it is free to rotate. It is free to rotate along 360 degree. Correct? So whenever you are having a rotary type of a motion, so this comes into picture, that is angular displacement. When you consider this as a OA as a kinematic link, this is the first position and it is rotating in a clockwise direction. After that, it will reach this OA1, so the dotted line, correct? So you can consider this as a angular displacement. What is the angle that is covered by this kinematic link? That is nothing but angular displacement, correct? Angular displacement. That is denoted by theta and it should be in radians. And when you differentiate this angular displacement with respect to time, okay, as the time changes, the displacement also changes. It means d theta by dt, it comes under angular velocity. It means the rate of change of angular displacement is angular velocity. It should be in radian per second. And again, when you differentiate this omega, the angular velocity, you'll get angular acceleration, that is alpha, d omega by dt. So this is nothing but rate of change of angular velocity, which comes under angular acceleration, correct? Radian per second square. It means as the kinematic link starts rotating, the velocity changes with respect to time. Okay. Now at the existing time, it may be 5 radian per second. After 10 seconds, it will increase 10 radian per second. It means that it keeps on changing. The velocity, the angular velocity keeps on changing. So I can call it as a angular acceleration. It is alpha. And one more thing is this is a OA kinematic link, and it is having a displacement that is delta theta. It has rotated from initial position OA to final position OA1. Okay, whenever this angle is very small, delta theta, so I can consider this as a straight line. Okay, and this kinematic link, that point A, it is going to trace this arc, correct? And whenever it will be rotating like this, it will trace this arc, and this is A to A1 directly adjoint. Whenever just make a note, whenever the angle is very small, so I can consider the length of this A1, the straight line, and the length of arc as the same, almost same, when the angle is very small. So based on this, I'll get the velocity of point E. This derivation is not required because you'll not get any question on the derivations in the examination. So only just take care of the formula. Okay. Whenever the kinematic link OA is rotating in a clockwise direction or counterclockwise direction, but in this case it is rotating clockwise direction. It has traveled through a angular displacement that is delta theta. You can consider it is a very small, and OA is the initial position, OA1 is the final position, and point A is the tracing this arc. Okay, whenever the angle is very small, I can consider this distance, the shortest distance between A and A1, and this arc as same. Line AA1 is equal to arc AA1. Length of AA1 and length of arc AA1 I can consider as the same for small angular displacement. So after that, the derivation is not required. So I'll get the velocity of point A. With what velocity point A is moving along the straight line. Okay, so you can consider this as a point, the velocity of point A. Just note on this, only this is required. Only you know this in the second module. Okay, using this formula you calculated the velocity of different kinematic links. VA is a velocity of point A, and OA is the length of kinematic link, OA, length of the kinematic link, and omega is the angular velocity, the rate of change of angular displacement with respect to time. Okay, so whenever you want to find out the velocity of any point on this kinematic link, you need to multiply the distance, that is OA, into omega, that is angular velocity. Don't worry about the derivation, only note on this. Okay, so again the same figure. This is the kinematic link OA, and this red color arrow mark. So this is nothing but the velocity of point E. This is nothing but the multiplication of the length of the kinematic link, that is OA, into omega, the angular velocity. And we'll assume that, so this will be at 90 degree. The direction of this vector, the velocity vector, always it will be at 90 degree for small angles. Remember this. For small angular displacement, I can assume that this is always at 90 degree. Correct? So already I have discussed this also. Then after this, yeah, just wait for a second. Yeah, just take down this figure. Before I start with the actual problems, I'll list down what are the required formula. Yeah, so please consider this as a vector AB. Please draw a rough diagram of this vector, that is vector AB. So I can consider this point A, the initial point of the vector, as a tail of the vector, and this point B, the final point of this vector, as a head. Is the tail, is the head. Okay, remember that. And the length of this vector AB is R. You can consider as a 5 centimeter or 10 centimeter. And it is making some angle theta with respect to the positive real axis. Before I explain this, let me show what is exactly positive real axis. Okay, so I'll draw a vertical axis. Okay, and that I'll mention this is a positive imaginary axis and this is a negative imaginary axis. And I'll draw a x-axis. So this I can indicate as the right part as a positive real axis and the left part as a negative real axis. So this is the real axis and this is the imaginary axis. So please draw a rough diagram. And this is a representation of the vector. the same vector whatever I have shown on the slide. This is the vector OA. Okay, vector OA. Please draw this vector OA, and this is the origin OA. This is the origin point O. So I can call this point O as a tail of the vector, point A as the head of the vector. And the length of this vector is given as small r. And so this is the positive real axis, right? So you can consider this. Remember this. Always we'll measure the angle of this vector always with respect to the positive real axis. Remember this. And in anti-clockwise direction or the counter-clockwise direction. This is also very important. Please make a star point. Always the angular displacement of this vector OA has to be measured with respect to the positive real axis in counterclockwise direction. Okay, and you have to take the reference as tail of the vector, not the head of the vector. Okay, you take the reference as tail of the vector, positive real axis in counterclockwise direction. Okay, and this derivation is not required, and I can represent this vector, the displacement. Displacement, it means initially the vector may be here along the positive real axis. It is rotating in counterclockwise direction to some angle. It means there is a change in position of the vector. So I can call it as a displacement. So I can indicate this displacement of this vector having length r and theta as r e raised to I theta. Just remember this. The derivation is not required. The displacement of any vector OA having length r and the angular displacement theta in a counterclockwise direction with respect to the positive real axis can be denoted as r multiplied by e raised to I theta. Only this formula is sufficient. And this e raised to I theta is nothing but cos theta plus I sin theta. Only these two equations are required. Okay. Please note on this. This is very important. So r is the length of the vector OA and theta is the angle made by vector OA with respect to positive real axis. Just underline this word, in a counterclockwise direction. In a counterclockwise direction. So any doubts, please let me know, because this model is very important from exam point of view. You'll get similar problems. Almost 90% of the problems will be repeated, same type. Only the angles will be different, the distance will be different, the method will be same. That's why please take care of all these formulas. Okay. So far I'll revise once again. I've discussed what is exactly a motion. There is a change in displacement or change in position. So I can call it as a displacement or the motion. The planar motion, spatial motion, straight line motion of the piston, rotary motion, that is a crank, combination of both straight line as well as rotary, that is connecting rod. And I consider the linear motion of the object, that is nothing but I'll get three parameters. So when there's a change in position in a straight line direction, I can call it as a linear displacement. When you differentiate this linear displacement, you'll get linear velocity, that is v is equal to ds by dt. Again, when you differentiate this linear velocity, you'll get linear acceleration, that is a is equal to dv by dt. This is for linear motion of any object. And when the same object starts rotating either in a clockwise or a counterclockwise direction, the displacement I can denote as theta, that is angular displacement. Okay, this is linear, this is angular. And when you differentiate this, you'll get omega, that is angular velocity. Again, when you differentiate this, you'll get angular acceleration. After that, I consider a kinematic link OA, and it is moving in a clockwise direction. OA is the initial point, OA1 is the final point. I need to find out with what velocity the point A is traveling from A to A1. So I got this formula. The velocity of point A of vector OA as OA into omega. OA is the length of the vector, the length of the kinematic link into angular velocity omega. This is the first formula I have discussed. And always the velocity of vector OA, it will be perpendicular to the length of this kinematic link whenever the angle of displacement is very, very small. And after that, I discussed what is exactly analysis and synthesis. Okay, in analysis, the system will be there and you will be knowing the inputs. Only you need to find out the output. For given system, for given input, what is the output and what is the relation between input and output. If I am going to increase one parameter, the one input parameter, what is the change in the output? Whether it is directly proportional, whether it is indirectly proportional, or okay. So these are the conditions for analysis. And for synthesis, input is known, and the possible outputs are also known. That is, the requirement is also known. Based on these things, you need to design the length of the kinematic link, the velocity of kinematic link, all those things. The fabrication related parameters you have to decide. Only this is the change. And after that, so how to represent any vector? Okay, the displacement of any vector OA. This is the positive. This is the axis. The right part of this origin is nothing but the positive real axis. So this is the negative real axis, and in the vertical direction, the y direction above O, I'll consider this as the positive imaginary axis, and this is the negative imaginary axis. And this is the vector OA having length r and making an angle theta in the counterclockwise direction with respect to the positive real axis. So I can say the displacement, the angular displacement of this vector OA as r e raised to I theta. So this is the second formula I have discussed, where e raised to I theta is cos theta plus I sin theta. So if it is clear, I'll solve some problems, some exercise problems. And before that, yeah. So this is the vector AB having length r, and it is making theta in a counterclockwise direction with respect to positive real axis. And you have to measure the angle where there is a tail of the vector. The reference is tail of the vector and the positive real axis. Okay. And as I said, the displacement or position of this vector AB at this point, it is denoted by r into e raised to I theta. And when you differentiate this one, the displacement, the angular displacement of this vector, okay, so you'll get the velocity of vector AB as r into omega e raised to I 90 plus theta. The derivation is not required, even though I'll provide a note, the detailed derivation, but it is not required for the examination. Only these formulas sufficient. When you differentiate this displacement, you will get the velocity of vector AB, that is r into omega e raised to I 90 plus theta. Please write down this. Again, when you differentiate this velocity, you will get acceleration of vector AB. Acceleration of vector AB, that is r in bracket omega square e raised to I 180 plus theta plus alpha e raised to I 90 plus theta. Where omega is the angular velocity of this link AB, and alpha is the angular acceleration. So please take a minute and write down these three formulas. Yeah. Shall I move to the next slide? Anyone please reply? Yeah, thank you. Yeah. Pardon me, what is exactly, I'm not getting your doubt. Small? Just ask the question once again. Yeah. Yeah. Please note down this exercise. First exercise. So again, I'll consider this a vector x, y. Okay. So this is the tail of the vector. Okay. That is point x, the initial point. The final point, that is y, as head. And it is given this vector xy, it's having a magnitude or length. It means the vector means it will be having the magnitude and the direction, correct? And the magnitude or the length of this vector or this magnitude is 100 meter per second. Okay, and it is making an angle of 120 degree in counterclockwise direction with respect to the positive real axis. and I need to find out the displacement of this vector xy. So using the formula, these three formula. So let me write what is the displacement. I don't want the velocity and acceleration. I want only this displacement. This formula, r into e raised to I theta. R is the magnitude of the vector. Theta is nothing but the angular displacement in a counterclockwise direction with respect to the positive real axis. And you know what is e raised to I theta? It is nothing but cos theta plus I sin theta. Correct? Anyone please write down what is the displacement of this vector? So I can give the formula. So you just indicate the vector, okay, xy. The displacement of the vector is equal to r into e raised to I theta. R is nothing but the length of this vector, that is xy into e raised to I theta. The xy is 100, right? And I'll keep it as it is. Theta is always, remember, theta is always, it has to measure in counterclockwise with respect to positive real axis and with respect to the tail of the vector. So it is 120. I know e raised to I theta as cos theta plus I sin theta. So I'll write cos theta plus I sin theta. So this is nothing but the displacement of this vector xy. If you want, you can write the velocity and acceleration. Okay, as of now, I want only the displacement, not the velocity and acceleration. So if you substitute in this formula, I'll get the velocity of the vector and the acceleration. But I'll try to write only the displacement for the time being. Any doubt in this first exercise? Please let me know. I'll go to the next one. Whether you have noted down this solution. Anyone, please reply. Otherwise, I'll go to the next slide. Yeah. Okay. Thank you. And I'll take the next exercise. Please concentrate. Again, the vector name is xy. X is the tail of the vector or the initial point, and y is the head of the vector. And its magnitude is given as 250 meter per second. And this is a positive real axis. But in this problem, so they have given the angle, this 150 degree, with respect to the negative imaginary axis. So this is the positive real axis, negative real axis. Above is the positive imaginary axis, negative imaginary axis. So they are given the angle, that is 150 degree, with respect to the negative imaginary axis. So please try to write down the displacement or position of this vector xy using the formula r into e raised to I theta, the same formula. And remember, the theta has to be measured with respect to the positive real axis. I want this angle in a counterclockwise, but the given value is clockwise. Remember, I don't want this one, because the reference they have taken is this one, the negative imaginary axis. As per the rule, always I need to locate the angle with respect to positive real axis in a counterclockwise direction and with respect to the tail of the vector. Anyone please try? Correct. What is this angle? 120, right? Correct. So this angle I need to find out, that is 120 in counterclockwise. Now what is the equation you got? Last equation. R into e raised to I theta. R is 250. 250 into R raised to E I 120. Correct? Whether you got the same answer? Yeah. Let me know whether you got the same answer. Anyone? Yeah. Thank you. So this is very important. From when I'm going to solve the problems, right? I'll not repeat these things. Always these. I think these parameters or these rules has to be taken care. Okay. If you got the correct answer, I'll go with the next one. Yeah. So again, there's a vector xy. Right. The angle is not given, and this is the positive real axis. The magnitude of this vector is given as 150 meter per second. The angle in the sense it is 90 degree or in a downward direction along the negative imaginary axis. Try to write down the displacement of this vector xy as per the rules. The rule is always you have to locate the angle in counterclockwise with respect to positive real axis, and you have to start from this tail. Take the reference as tail. Anyone please give the answer? What is the displacement of this vector? Correct. Because this angle is 270 and it is in counterclockwise with respect to positive real axis and the tail. So I can write 150 into e raised to I theta, that is theta is 270. E raised to I theta is cos theta, that is cos 270 plus I sin 270. Right. Whatever you got, the answer is right. What is your name? Let me know. What is your name? Yeah, thank you, Darshan. After that, any doubts? So please let me know. Others. So this class is very important. In any in YouTube. Yeah. What is the doubt? Yeah, this is the given problem. Let me know your name. Somebody is asking the doubt, right? What is your name? Aditya, what is exactly the doubt? The length is given, that is the magnitude of this vector is given, and it is in a downward direction. Okay. The total is 360, right? Total angle is 360. As per the rule, always you have to start from the tail of the vector and positive real axis, correct? So this is my reference always. So with respect to this, how much it is? I know this is a 90. Total is 360. 360 minus this 90, you'll get 270. 90, 180, 180 plus 90, 270, correct? You got the answer? Okay. So I got the answer with respect to the positive real axis, the counterclockwise. The conditions are satisfied. So I'll take this as the angle. So in the theta, I'll write 270. In the xy, I'll write the distance, that is 150. Yeah. And a raised to I theta is nothing but cos theta plus I sin theta. And above this xy, just indicate the vector. It's a representation of a vector. Okay. And after that, I'll go with the next one. So please draw this. Just take a minute and draw this vector AB. And A is the tail of the vector, B is the head of the vector. The magnitude is the 50 kilonewton. It is moving in a downward direction in such a way that the angle is 45. Angle made by this head of the vector, 45. So please let me know the displacement of this vector AB. Follow all the rules, the three rules. You have to start from the tail, you have to start from the positive real axis, you have to start in the counterclockwise direction. Just find out the theta, you'll get the answer. Huh. 225, right? So it means this is a 45, right? This is also 45. So this is total 180 plus 45, 225. Yeah, right. So I got the angle, that is 225. So I'm not going to consider this angle because so this angle is with respect to the head of the vector. But as per the rules, I need to calculate from the tail. Even though this is the positive real axis, but it is with respect to the head. So I'll not consider this. So I want this, the tail, positive real axis. So this will be 225. If you want, you can calculate this is a 90 and this is a triangle. So in the triangle this will be 90. So automatically the total angle, the interior angle of this triangle is 180. So we'll get this as a 45. 180 minus 90 minus 45. This will be 45. So you can 90 plus 45 minus 360. You can calculate as per your convenience. Otherwise, you can use exactly this is a 45. So this will become 45. 180 plus 45, 225. So what is the answer? You got the answer. This one. R into e raised to I theta. R is nothing but the length of the vector AB, that is 50. Theta is 225, and you get the answer as a 50 cos theta, cos 225 plus I sin 225. You got this answer? Anyone? Yeah. Thank you. And I'll go to the last, I think, last equation, last problem, yeah, last exercise. Yeah. Just take the vector PQ, vector PQ. It is having a tail at point P, head at the point Q, and it is having the magnitude 100 kg, and it is making an angle 70 with respect to the positive real axis and with respect to the tail as the reference, but the direction is clockwise, no doubt. But I want counterclockwise. As per the rules, I want counterclockwise. How much it is? Yeah, right, 290 in a counterclockwise, correct. Okay, take care of the directions. Okay, the given direction is clockwise, I need a counterclockwise, correct, 290. Then what is the answer? The final answer? R into e raised to I theta. Right, correct. Yeah, thank you. So please note on this. If it is clear, I'll take another 10 minutes. I'll take another 10 minutes. I'll go with one more small topic, that is a loop closure equation. So if it is completed in the today's class, I'll go with the problems in the next class. Yeah. Yeah. Whenever you want to find out the displacement of the vector, you have to take the angle in a counterclockwise. Only when you want to represent the vector PQ. Okay. As the problem starts, there are some more sign conventions. I'll let you know. Okay, no problem. Yeah, please mute your audio. Yeah, Prajwal. Prajwal, please mute your audio. Yeah. And if it is clear, after that, yeah, please. There's one more sign convention before that. So these are the derivations you can go through later. Directly I given the formula. Okay. So the angular, the velocity, this is the velocity of the vector, and the acceleration. Already I given the formula. The derivations are not required. And please take the next heading, that is a loop closure equation. Loop closure equation. I'll take another 10 minutes and I'll try to wind up today's class. Loop closure equation. Please take the statement also. Just take a random group of vectors, a closed profile of the vectors. So there is a vector AB, it is moving in a clockwise direction. BC, it is also clockwise. CD, TE, EF, FG, GH, and HE, all are moving in a clockwise direction. Whenever there is a kind of this closed profile, or any mechanism of this kind, so I'll indicate all the kinematic links of that particular mechanism in terms of vectors. So that it will be easy to find out the displacement, velocity, and acceleration. I'll represent, once again I'll repeat, I'll represent the kinematic links of any mechanisms having a closed profile into vectors. So this is one kinematic link I can represent as a vector AB. This is one more kinematic link I'll represent with a vector BC, the similar manner. I can represent the kinematic links in the form of vectors, so that I can find out the displacement vector, sorry, the velocity and the acceleration. And this loop closure equation states that whenever there's a kind of this closed loop or the closed profile, the summation of all the vector displacement, this the summation of all the vector displacement is 0. Okay, and you have to take into one order. I'll explain what is exactly how to take the orders. The sum of the relative positions or the displacement of the vectors of the links or the kinematic links forming a closed loop in a mechanism taken in order always 0. Just consider this as a mechanism having different kinematic links 1, 2, 3, 4, 5, 6, 7, 8. I think it is having 8 kinematic links. I'll replace the kinematic links with a vectors, that is vector AB, BC, CD up to HA. You can give any random direction, either clockwise, counterclockwise, as per your wish. And after giving the directions, first I'll take all the directions in the clockwise. AB is also moving clockwise, BC is also moving clockwise for my convenience. And I'll take the summation. So in the previous slide, I think you calculated the displacement, right? So this is the displacement. So when you take the displacement of this vector, all the vectors, and you consider the displacement of this vector, that is AB, that is r into e raised to I theta. When you consider the displacement of this vector, again r into e raised to I theta, r is nothing but the length of individual links. And when you take the summation of all the displacement of all the vectors, it will be 0. Since all are moving in a clockwise, so I can take all as a positive. I'll take some problems. I'll take one problem so that I can say when to take positive and when to take negative. Okay. Only take the statement of this loop closure equation. The sum of the relative position vectors or the displacement of the vectors for the links forming a closed loop. As I said, the profile is closed in a mechanism. This is a mechanism. So taken in order, I am taking in a clockwise order. So just take the summation of all these vectors, it will be 0. So this vector AB indicates the displacement of this vector. So what is the formula? R into e raised to I theta. R is the length of the vector AB. Theta is the angle you need to measure in a counterclockwise direction with respect to the tail. You have to write down this. Similarly, just take the vector BC. That is r into e raised to I theta. R is the length of the vector BC. Theta I need to calculate on a counterclockwise direction with respect to the positive real axis. It comes in a later part. Only just take this summation of all these vectors in a closed profile taken in particular order is always 0. So if it is clear, I will take one more case. I'll take a 4-bar mechanism or a 4-bar chain. So just take this as a case 1. So I'll indicate all the kinematic links, all the 4 kinematic links with a vector, that is PQ, QR, RS and SP. And I'll write down the displacement vector of this PQ, that is PQ. Since all are moving in a clockwise, so I'll take the direction of all the vectors. For my convenience, I'll take the reference as clockwise. For my convenience, if the vectors are moving in a clockwise, I'll take it as a positive. If it is moving opposite to the reference, that is clockwise, counterclockwise, I'll take it as a negative. So you can take any one as a reference. For my reference, the clockwise vector is positive, the counterclockwise vector is negative. Since PQ is clockwise, QR is positive, the clockwise, RS, SP all are positive. So I'll take plus plus plus, I'll make the summation and the summation will be 0 as per the loop closure equation. So this is the loop closure equation for this mechanism. First there will be a mechanism. You need to indicate all the kinematic links in the form of vectors, and you have to take the summation of the vectors, the displacement of individual vectors. If all are clockwise, take positive. If anyone is negative, if anyone is counterclockwise, take it as a negative. And always while representing, always you have to start from the tail. This is the tail of the vector PQ. You have to write PQ, QR, RS, SP. You have to start from the tail, you have to end with the head. Okay. So this is the first case, and so please take the second case. So try to write down the loop closure equation of this mechanism. Again, there is a 4-bar mechanism. Okay, so you can take the direction as per your convenience. So now what I'll do, I'll replace all the kinetic links with the vectors, and first vector I'll take in a clockwise PQ, second vector is also clockwise, third vector RS is also clockwise. What I'll do, I'll change the direction of this vector PS in a reverse order. I'll take it in the counterclockwise. And the reference is this always, the initial point is the PS. As I said, the clockwise vectors will be taken as positive, the counterclockwise vectors will be taken as a negative. And you have to write the vector in such a way that you have to start from the tail of the vector and you have to end with the head of the vector. That is PQ, QR, RS and minus PS, because it is opposite. You can see here. This is the vector PQ. I started with a tail PQ, then QR, RS, all are in the clockwise direction. I'll take it as a positive, positive, positive. And when it comes this vector PS, it is in a counterclockwise direction. It is opposite to the given order. The reference order is clockwise, but it is opposite to the reference. That is counterclockwise. So I can indicate with minus PS. You can say why you have to take SP. No, because I have to start from the tail of the vector. This is the PS, the vector PS, the tail is P, head is S. That's why I'll write PS, not SP. Since it is counterclockwise, opposite to this order, I'll indicate with minus, the summation will be 0. Okay, if you know the magnitude and the angle, you can write R into I raised to I theta. That is PQ e raised to I theta, QR e raised to I theta, RS e raised to I theta minus PS e raised to I theta. And theta will be with respect to that vector. In the counterclockwise, with respect to positive real axis and the tail of the vector. So for each vector, you need to calculate the angle. So in the exercise, I think I calculated the angle for each vector, right? Now you got 4 vectors at a time. So you'll get 4 angles with respect to PQ, with respect to QR, RS and SP. So it will become a loop closure equation. And I'll take the last case. Yeah. So please note of this, case 3. So I've changed the direction of the vectors. You can take any directions. You'll get the final answer as the same. I want the loop closure equation of this mechanism. Take the summation of the vectors. If they are in a clockwise, take positive. If they are in a counterclockwise, take negative. Anyone please tell me the loop closure equation of this mechanism? Yes. Correct, right, correct. PQ plus PQ is a clockwise, PQ, QR is also clockwise, and SP, SR is counterclockwise, opposite to the reference one is clockwise. So here the reference you can take any one. You can take the reference as counterclockwise or clockwise. Okay, it asks for your convenience. Now I have taken the reference as clockwise, so clockwise as positive, counterclockwise as negative. PQ is clockwise, I'll take positive. QR is clockwise, positive. SR is counterclockwise, so negative. And PS is also counterclockwise, negative. The summation will be 0. So this is how you have to write the loop closure equation for a closed profile of the closed mechanism. Okay. And one more note, please take on this. If there is a vector Z, and you can indicate that vector in the form of x plus I by. If you consider any vector, as I said, cos theta plus I sin theta, if you take any vector, it can be represented as x plus I y. So where x is the real part, plus, and the parameter that is along with this I, the imaginary one. So this parameter is considered as imaginary part. Except I, whatever there is there, you can consider that as an imaginary part. This is also very important. And there is a vector z x plus iy. This part is called as a real part, and the parameter or the variable which is there with along with I, this will be considered as imaginary part. So this is very much important while solving the problems. Yeah, and just take this also note: the sign conventions for velocity and acceleration. So this one I have taken as per my convenience. Counterclockwise as a positive, clockwise as a negative. So this is the case of indicating the velocity and acceleration, not the displacement. Don't confuse with the displacement. So these are nothing but the displacement vectors. So here I have taken clockwise as a positive, counterclockwise as a negative. But when you're going to note down the velocity and acceleration, you have to take this sign convention only. If you want, you can change, but you have to follow the same for all the problems. For my convenience, for all the problems what I am to solve, I'll take this sign convention. Whenever the value of the velocity is a positive, it means it will be in a counterclockwise direction. And whenever the value of velocity or the acceleration is negative, it means it is in a clockwise. Okay? Don't confuse with the displacement and this velocity and acceleration. There are three parameters. One is the displacement, velocity, acceleration. For displacement, I can take clockwise as a positive, counterclockwise as a negative. And for the remaining two, that is velocity and acceleration, I can take it as a counterclockwise as a positive, clockwise as a negative. So after solving one or two problems, we'll get the clear idea. Okay. And this is the last problem of today's class. That is first problem of your model number 3. So I'll solve this problem in another 5 minutes, and I'll try to close today's class. So please write on this. Write the loop closure equation for the given mechanism. Write the loop closure equation for the below mechanism. So this is the mechanism. It means it is a group of so many vectors. Already I explained this in the loop closure equation. So here, so the same mechanism I'll take. So the angles are not given. I'll try to find out the angles. Okay. Again, the loop closure equation is same. But what I will do, I'll change the directions. Here I have taken all the vectors as a clockwise, but I'll change the directions so that you'll get practice. You can take any directions. Okay. You have the freedom of taking any directions, either clockwise, counterclockwise. Final answer will be same. Yeah. Okay. Write the loop closure equation for the given mechanism, and already the directions are given. If it is not given, you can take any order. You can give any direction. So first there is a vector AB. Okay. It is moving in a clockwise direction, and this the theta. The angle made by this vector AB with respect to the positive real axis in counterclockwise direction, and the reference as this tail of the vector. R1 is the magnitude or the length of this vector AB. So it is given, it is in clockwise. But what about this vector CB? Vector CB. Yeah. So magnitude is R2. Correct? The magnitude of this vector CB is R2. And they are given the angle theta 2. So you can see it is with respect to the positive real axis in a counterclockwise direction, and the reference is again the tail of the vector, that is C. Okay, and the third vector is CD. Again, it is a clockwise. Okay, C is the tail, D is the head of the vector. The length of this vector CD is given as R3. Correct, and the angle, as I said, you have to measure the angle with respect to the tail. Here is the tail of this vector CD. Here, point C is the tail. So this is the positive real axis. So I'll take this as a theta 3. Remember this, because it is counterclockwise and it is measured from the positive real axis. And the reference is tail, not the head. Don't confuse with that. Don't measure the angle here, because there is a head. I need from the tail itself. So that's why this is the theta 3. And I'll consider this vector ED. This is the vector DE, because the tail is D, E is the head. Vector DE, the magnitude is given R4, and this is the tail, so I will measure the angle here, theta 4, the counterclockwise with respect to positive real axis and the reference as tail. This is theta 4. So this is also clockwise. And when it comes the vector FE, so it is in a counterclockwise. With respect to the tail, it is counterclockwise. Sorry, it is a clockwise. Yeah. So this is counterclockwise, this is clockwise. And the magnitude of this vector FE is given as R5. And theta you need to measure in a counterclockwise, that is theta phi with respect to the tail and with respect to the positive real axis. This will be your theta phi. The vector direction is clockwise. So this is clockwise, AB, CB is counterclockwise, CB is clockwise, DE is counterclockwise, FE is again it is a clockwise. So just take the reference as AB. Okay, it is clockwise, counterclockwise, it is also clockwise, this is counterclockwise, this is clockwise, this is also counterclockwise, this is clockwise. Okay, so just fix the tail and try to rotate, you will get the direction. Okay, and you fix the tail of the vector AB, so it will be clockwise, it will be rotating clockwise as per the directions. So similarly, now at this point HG, the tail is H, so I will start from HG. The length is R7, just zoom this area. The length of this vector is R7, and the magnitude you have to measure from the tail with respect to the positive real axis, so theta 7. Okay, this is the 7th vector, so I can write theta 7. Last one is this HA, so it is moving in a clockwise direction. So HA, so the angle will be with respect to the tail, that is H, in a counterclockwise direction, that is theta 8. The magnitude is R8. Okay, so according to this, try to write down the loop closure equation. It means summation of vector AB, CB, CD, DE. Okay, if they are in the same direction, that is a clockwise, take it as a positive. If it is opposite to the reference vector, that is AB, make it as a negative. So I'll give the loop closure equation, but you need to find out the displacement of vector. So first I'll start from vector AB, so it is in a clockwise direction towards my right. Okay, I'll take the reference as clockwise, AB. Okay, so I can write AB as a positive. Next I'll go with this second vector, that is CB. It is opposite to this reference vector AB, so I'll take it as a negative because it is in a counterclockwise direction, this vector CB. So how to find out that? Just fix the tail and give the motion, it starts moving in a counterclockwise direction. Yeah, if you're getting confusion, take the first vector AB as the reference. The vectors along with this vector AB, they're moving along with this same direction, take it as a positive. If they're opposite to this vector AB, take it as a negative. So AB is moving towards right or clockwise or positive. CB is opposite to the vector AB, so it is a negative CB. Then CD is also along. You can see AB is same, it is moving like this. CD is also moving along in the same direction. So CD is positive. D is also moving along the same direction. That is CD. DE is also positive. When it comes, FE is opposite to this. It is against this vector DE, so it is negative. FE is negative. And when it comes into FG, again it is in the same flow. So AB, CD, DE, FE is also in the same flow, the same direction you can see. So this is also positive, that is FG. But when it comes into HG, it is opposite to this flow, this direction. HG is a negative and HA is a positive because it's along the direction of vector AB. So if anyone having this a confusion, please let me know. Since it is the first class, you may get some doubts. Okay, take a single flow. So AB is moving towards right or clockwise. I'll take the vectors which are moving along with this vector AB, the same direction, I'll consider as a positive. the vectors are moving in opposite or against of this vector AB, they are in the negative. They are in the negative sign convention. Okay, AB is positive, CB is opposite to this AB, CB is negative. CD is along the direction of AB, it is also positive. D is also along the flow of the vector AB, it is also positive. FE is opposite to the direction of this AB, it is negative. FG is along the direction, positive, is opposite, negative. HA is along. Okay, if they are moving in the similar order, similar direction, take it as a positive. If they are opposite, negative. After that, anyone just write down what is the displacement of vector AB. I think I have solved some problems, some exercise problems. How to write the displacement of vector AB. So already I have solved. So this r into e raised to I theta. If there is a vector having length r and the angle is known in the counterclockwise, so you can write that vector as r into e raised to I theta. Already I have solved these problems. So I want this answer. There is a vector xy having magnitude 100 and the angle theta. I can write 100 e raised to I 120. In a similar manner. So what is the displacement of this vector AB? R1, yeah, correct, correct. R1 e raised to I theta 1, right? You can see here. And what is CB? CB. The magnitude is R2, the angle is theta 2. It means R2 e raised to I theta 2. R2 e raised to I theta 2. Since the vector direction is opposite, because the vector AB is moving towards right, CB is towards left. So it is opposite to the flow of vector AB. So the direction is negative. Already I have discussed it. Take the same direction, that is the same convention minus. So CB is nothing but R2 e raised to I theta 2. CD, this is the vector CD. The length is R3 and the angle is here. Sorry, angle is here, this green color. Because it is a tail and this is the positive real axis. So this is the angle theta 3. It means R3 e raised to I theta 3. R3 e raised to I theta 3. Similarly for the vector R, this fourth vector, that is DE, the magnitude is R4, the angle is theta 4, it means R4 e raised to I theta 4. Then the vector phi, so this is the magnitude is R5, R5, angle is this theta phi, R5 e raised to theta phi. Since the flow of this vector is opposite to the first vector, it means it is moving against to the direction of flow. The flow direction is clockwise, towards right. It is moving against, so I will take negative. It is minus R5 e raised to theta phi. You can see the sixth vector, that is a FG. It is moving in the same order. It is the length is R6, angle is theta 6, R6 e raised to I theta 6. The next is the seventh one. It is again moving against to the all vectors, reference vector. It is minus R7, the magnitude, into e raised to I theta 7. The angle is this theta 7. So R7 e raised to I theta 7. Last one is the eighth vector, which is this one, HA. It is along the vector AB, so it is a positive. It means R8 e raised to I theta 8. R8 e raised to I theta 8. The summation will be 0. So if there is no doubt in writing the loop closure equation, then it will be easy to solve the next part of the vector, this problem, how to find the angular velocity acceleration. Okay. So this class was very important. Okay. So if there is no doubt in this problem, so I'll wind up today's class. Okay. In the next class, I'll start with the problem number 2. So this carries 20 marks. Remember, you'll get the same problem in the examination, only they'll change the data. The method will be same. This carries 20 marks. You'll get one single question. Okay, they'll change the type of mechanism. Either it may be a 4-bar mechanism or it may be single slider crank mechanism. Only 2 mechanisms. They'll change the angle. They'll change the given inputs. Okay, they'll change the length of the vectors. These vectors. The method is same. So it is approximately 7 to 8 pages. So I need 1 hour or 1.5 hours to complete this problem. Okay, but the problem is same. It same. The method is same for all the problems. Okay, this is a single problem. So please let me know if any doubts. Otherwise, I'll wind up today's class. Yeah. So earlier I discussed these sign conventions also. Yeah. So this is the second problem. It will be solved in the next class. Okay. So if it is clear, I'll wind up today's class. Okay.